Hello friends, welcome back to my channel. So in the last few videos we have seen how to check whether the given random process is wide sense stationary or not. So in this we will see another very important problem in this unit. Given an autocorrelation function, we have to find the magnitude of the mean value and variance of the given random process. So for this we will use the properties of the autocorrelation function which we have seen already. So if you are not seen, please go to my autocorrelation function definition and its properties video. So we'll use two of the properties to solve this video. So in that, one property that we are going to use today is if x of t, the given random process, is ergodic so here it is given the given autocorrelation function for a stationary ergodic process with no periodic component. So that is why we are using this property. So we have one property which is x of t is ergodic with no periodic components with no periodic components. Then we have limit mod tau tends to infinity rx x of tau is equal to mean square value, or this is also same as expectation of x whole square, So here autocorrelation function is given, that we will substitute here. Autocorrelation function is given, so limit mod tau tends to infinity rxx of tau is nothing but 625 plus 16 by 1 plus 36 tau square. Now if we substitute tau value infinity, so this will be equal to 625 plus 16 by 1 plus 36 into infinity square, as tau tends to infinity. So this will be the value, infinity is in the denominator, so this will be equal to 625. So limit mod tau tends to infinity rxx of tau value is 625, so which is nothing but mean square. So now if you take square root on both sides, if we take square root on both sides, square root of x bar square is equal to square root of 625. The square and root will get cancelled. We'll have mod x bar is equal to 25. So that is what we were asked, magnitude of the mean value. So this is the magnitude of the mean value is 25. Next we will use another property of autocorrelation function. We have autocorrelation function for a stationary process. In general we have rxx of t comma t plus tau. Rxx of t comma t plus tau is expectation of x of t into expectation of t plus tau. So in the problem it is given for a stationary ergodic process with no periodic components. So if the given process is stationary, then we can write rxx of tau, that is equal to expectation of x of t into x of t plus tau. Now if we substitute, tau is equal to 0, 0. On the right hand side, we have expectation of x of t into x of t. So which is nothing but expectation of x square of t. Expectation of x square of t. So we will get expectation of x square of t by simply substituting in the autocorrelation function tau value is equal to 0. So in the given problem statement, the autocorrelation function is 625 plus 16 by 1 plus 36 tau square. Now substitute tau is equal to 0 in this. So this will be 625 plus 16 by 1 plus 36 0 square. So this will be 625 plus 16. 625 plus 16. So which is equal to 641. 641. So expectation of x square of t, which is nothing but mean square value, which is nothing but mean square value. Now we need to find variance of the process. Variance of the process is nothing but expectation of x square of t minus expectation of x of t whole square. We know both the values. Expectation of x square of t is 641 minus expectation of x of t whole square. So which is nothing but 625, which is nothing but, so this is the mean value square. Mean value square is 625. Now if we substitute here, 641 minus 625, so that is equal to 16. So the variance of the given process, is 16. Variance of the given process is 16, whereas the mean value is 25. So these are the two things we were asked to find from the given autocorrelation function. So here we have used two properties. One property is this, expectation of x square of t we can get from the autocorrelation function by simply substituting tau is equal to 0. The other thing is we can get the mean value from this expression, limit mod tau tends to infinity rxx of tau, it will give you mean value square. So this is mean value square. This is a very simple and straightforward problem. If we know these two properties, this property of the autocorrelation function and this property of the autocorrelation function, we can easily find mean and variance of the given random process. I hope everyone is able to understand how we have found the variance and mean value of the given random process with the help of the properties of the autocorrelation function. Thank you for watching. If you are new to my channel, please subscribe to my channel and share with your friends and classmates. Thank you.